Have you ever gazed at the night sky, letting your mind wander among the stars and wondered where it all began? What secrets lie hidden in the darkness above us, waiting to be discovered? That curiosity links us to every human who's ever looked up in awe, from ancient storytellers to modern scientists. We live on a small planet orbiting an ordinary star, drifting through the vastness of space, in a galaxy among billions scattered across the universe, each one a cosmic island with its own mysteries. The universe is everything, every star, planet, and even the space between. It's a tapestry woven from light, matter, and time itself. To understand our place, we must explore its origin and unravel the story of how everything came to be. This isn't myth, but a story built from observation, mathematics, and scientific discovery, evidence gathered over centuries. It all began with an unimaginable bang, a moment that set everything in motion. We'll journey back to the first moment of existence, to a time before stars, planets, or even atoms existed. Imagine the universe when it was smaller than an atom and began to expand, a transformation beyond comprehension. All matter and energy compressed into a single, infinitely dense point, a state where the laws of physics as we know them simply break down. From this singularity, the universe burst forth, expanding and cooling, giving rise to everything we see today. Not as an explosion in space, but as an explosion of space itself. Space stretching, time beginning, and the cosmos awakening. By learning about the universe's beginnings, we learn about ourselves and our connection to the cosmos. The atoms in our bodies were forged in ancient stars. We are, quite literally, stardust, born from cosmic fire. So let's begin our journey to the dawn of time, to explore the wonders and mysteries that shaped our existence. Together we'll witness the birth of the cosmos and discover how the universe came to be. The universe's story begins 13.8 billion years ago with the Big Bang, a moment that marks the dawn of everything we know. It wasn't a bang in space, but the birth of space and time itself, a transformation so profound it's almost beyond imagination. Everything, matter, energy, even time, sprang from an unimaginably hot, dense point smaller than an atom, yet containing all the ingredients for the cosmos. The universe began expanding rapidly, like dots on a balloon moving apart as it inflates, stretching space itself in every direction. This expansion set off a chain of events leading to everything we know, from the tiniest particles to the largest galaxies. In the 1920s, astronomer Edwin Hubble made a groundbreaking discovery. Distant galaxies are moving away from us. The farther they are, the faster they recede, revealing a dynamic, ever-changing universe. This was the first solid evidence that the universe is expanding, not static as once believed. If we rewind this process, everything, every star, planet, and atom converges to a single, unimaginable origin. The Big Bang Theory, supported by the expansion of space and the faint afterglow of the cosmic microwave background we still detect today, is our best explanation for the universe's beginning. It tells us the universe had a start, has been evolving ever since, and continues to change with every passing moment. This revolutionary idea replaced the old belief in a static universe with one that grows, transforms, and surprises us. The Big Bang is not just a theory. It's the foundation of modern cosmology, shaping how we understand our place in the cosmos. And as we look deeper into space and time, we realize this is only the beginning of our cosmic story, with countless mysteries still waiting to be explored. In the first instant after the Big Bang, the universe was pure chaos, hot, dense, and indescribable by today's physics. All four fundamental forces were likely unified, but as the universe expanded and cooled, they separated, shaping the laws of nature. A split second later, cosmic inflation caused the universe to balloon in size, smoothing it out and stretching tiny quantum fluctuations into the seeds of galaxies. After inflation, the universe was a hot soup of particles, quarks, leptons, and photons, constantly colliding in a dense, opaque fog. No atoms, no stars, just a seething plasma. As it cooled, a tiny imbalance left a bit more matter than antimatter. That tiny surplus is why anything exists at all. Every star, planet, and person is made from that leftover matter. We are the survivors of a cosmic battle between matter and antimatter. From chaos the building blocks of everything began to emerge. For the first few minutes after the Big Bang, the universe was unimaginably hot and dense. At this stage, it was far too energetic for atoms to exist. Matter was just a seething plasma of protons, neutrons, and electrons, all zipping around at incredible speeds. The forces binding particles together were constantly being broken apart by the intense heat, preventing the formation of even the simplest atoms. As the universe expanded, it began to cool. This cooling allowed protons and neutrons to come together, fusing to form the very first atomic nuclei. Most of these were hydrogen, the simplest and most abundant element, but some helium and a tiny trace of lithium nuclei also formed during this brief period known as Big Bang nucleosynthesis. For hundreds of thousands of years after, the universe remained a glowing, dense fog. Free electrons roamed everywhere, scattering light in all directions and making the cosmos opaque, like a thick cosmic soup where light couldn't travel far. Then, about 380,000 years after the Big Bang, the universe cooled enough for electrons to slow down and combine with nuclei. This process, called recombination, allowed the first stable atoms, mostly hydrogen, to form, transforming the universe forever. With atoms now able to exist, the universe became transparent for the very first time. Light, which had been trapped, could finally travel freely across space. This ancient light, released at the moment the fog cleared, is what we now call the cosmic microwave background, or CMB, a faint glow that fills the entire universe. The CMB is the afterglow of the Big Bang itself, a fossil snapshot capturing the universe as it was in its infancy, just as the first atoms formed. Over billions of years, as the universe expanded, this light stretched into microwaves. Today, we can still detect it using sensitive instruments, revealing secrets from the dawn of time. The CMB remains one of our strongest and most direct pieces of evidence for the Big Bang, confirming our theories about the universe's origins and evolution. By studying this ancient light, we peer through a cosmic window into the universe's earliest moments, unlocking the story of how everything began. After the universe became transparent, it entered the cosmic dark ages. No stars, just drifting clouds of hydrogen and helium. But gravity began pulling denser regions of gas together, compressing them over millions of years. As these clouds collapsed, their cores heated up until nuclear fusion ignited. The first stars were born, ending the darkness and lighting up the cosmos. These stars were giants, massive, hot, and short-lived. They burned through their fuel quickly and exploded as supernova, scattering heavier elements like carbon and oxygen into space. These elements became the raw material for new stars, planets, and eventually, life. The first stars transformed the universe, seeding it with the ingredients for everything to come. Their light marked the end of the cosmic night. The universe was ready for the next act, the rise of galaxies. The first stars formed in clusters within dense gas clouds, and gravity kept sculpting these regions. Over hundreds of millions of years, star clusters and gas merged, forming the first proto-galaxies, chaotic, irregular, and full of collisions. These proto-galaxies combined to create larger, more organized galaxies. Our Milky Way is the result of countless such mergers, a process still ongoing today. Many galaxies flattened into spinning disks, forming beautiful spiral arms where new stars are born. Each generation of stars enriched the cosmos with heavier elements, making rocky planets and complex chemistry possible. Today, powerful telescopes let us look back in time, observing galaxies as they were billions of years ago. By studying distant galaxies, we piece together the story of how the universe evolved. The tapestry of galaxies is the universe's grandest masterpiece. Our understanding of the universe is built on the work of generations of scientists. Albert Einstein's theory of general relativity showed that gravity is the curvature of space-time, predicting an expanding universe. Edwin Hubble's observations confirmed that galaxies are moving away from us, proving the universe is expanding. Georges Lemaitre proposed the idea of a cosmic beginning, a primeval atom. George Gamow predicted the Big Bang's afterglow, the cosmic microwave background. In 1965, Arno Penzias and Robert Wilson accidentally discovered the CMB, confirming the Big Bang theory. These discoveries transformed cosmology, turning speculation into science. The quest to understand the cosmos is a collective human achievement. Why do we seek the universe's origins? Because curiosity is at our core. Our drive to explore and understand has led to discoveries that shape our world. Technologies from astronomy, like image processing and radio detection, now help us in medicine and communication. Studying the cosmos gives us perspective, reminding us of our shared home and our responsibility to protect it. The story of the universe is our story. The elements in our bodies were forged in ancient stars. By tracing the cosmos, we trace our own origins. We are not separate from the universe, but a part of it. In seeking to understand the cosmos, we are the universe becoming aware of itself. Our quest for knowledge connects us to the stars. Despite all we've learned, mysteries remain. What happened in the very first moments of the Big Bang? Our physics breaks down at the singularity. We need new theories, perhaps quantum gravity, to understand time zero. Dark matter is another puzzle, invisible, yet shaping galaxies with its gravity. It makes up about 27% of the universe, but we don't know what it is. Then there's dark energy, driving the universe's accelerating expansion. An unknown force making up 68% of everything. All the stars, galaxies, and people are less than 5% of the universe. Are there other universes? What is our universe's ultimate fate? The story of the cosmos is still being written, and the greatest discoveries may lie ahead. The universe invites us to keep exploring and never lose our sense of wonder.